Hey everybody, I am out again obviously today. You have some notes to go through on a couple of modules and there's a ton of terms here. So I'm going to suggest that you read the section and you actually go through these notes. I know it's a whole lot more useful if we can talk to each other, but it is what it is. And I want to try to keep us on track because we all know the AP test is coming up in the near future. So I took a COVID test yesterday, an at-home test, and was negative. I'm still having some symptoms, nothing super major, but they're telling me I have to test again today. So I am doing that, and we'll see. I'm hoping to be back tomorrow. So if you go in, you can follow along with the notes if you'd like, or you can just compare to your own notes. The section on thinking is term heavy, and so I'm going to suggest that this is a great unit for Quizlet because there's a lot of stuff there. Let's start with the term cognition. So cognitive psychology, cognition, anything related to thinking, knowing, remembering, communicating, it all falls within that frame. So we're going to talk about some other things beyond just memory today, but how we actually solve problems, how we understand things, how we, make decisions. We'll get into that. Tomorrow, I think we get into language and how that relates to thinking. So, we're kind of framing out the different ways that cognitive psychology plays out. So this is what cognitive psychologists do, right? They look at the ways that people in either logical or illogical ways create concepts, solve problems, make decisions, form judgments. So we're going to just dive right in and go. The nice thing about this, I guess, is if I'm going too fast, you can pause. Or you could probably skip ahead if you're bored of me. But one way or the other, you'll have the control. I found this quote. There's a guy named Daniel Gilbert. He wrote a book called Stumbling on Happiness, and it kind of blew my mind. If you think about this for a second, it's kind of wild, right? The average newspaper boy in Pittsburgh knows more about the universe than Galileo, Aristotle, Leonardo, or any of those kind of enormous figures in history knew. And if you think about that, like just the place we are in the world, the amount of information that's coming at you on a daily basis, you guys are processing more and know more than some of these huge thinkers in history, right? So the first chunk is thinking. So we'll talk about concepts. We'll get into solving problems. We'll then work our way towards making decisions and forming judgments. Okay, so let's start with concept. Concept is defined as the mental grouping of similar objects, events, ideas, or people. So how do we organize information in our brains? We put things into concepts. So the example we have here is the concept of a chair. So looking at all of these different examples of chairs, they're all different and kind of unique. What do they have in common? Common features define the concept of a chair. If I was with you, I would have you determine what are those common features. And, it actually is more complicated than you think, right? It's not necessarily the number of legs because some of these have 3 legs, some of them have 4 legs, some of them have really 1 leg with a base. It's probably has something to do with you're off the ground and it has a back on it. If it doesn't have a back, we call it a stool, not a chair, right? So this is how we mentally group objects, events, ideas, or people. We put things into concepts, okay? We then organize concepts into category hierarchies. So we have, animals as kind of the big, the broad category way up at the top. And then we can break animals down into domesticated and wild animals. And then we can break down domesticated animals into all kinds of different categories, right? To the point where we get down to specific breeds of dogs, for example. Okay. How how do we develop concepts? It says we form some concepts with definitions. For example, a triangle has three sides. But then you know that there are different kinds of triangles, right? Depending on, I guess, your math background here. So things can get more and less complex depending on where we want to go with it. The prototype is another term that is a mental image or a typical example. So the example here is if I asked you to think of what is a bird, what's the typical example of a bird, you're probably more likely to tell me something that's like a robin as a typical bird as opposed to a penguin, right? We know a penguin's a bird, but it's kind of a weird bird, right? It doesn't fly, they waddle, all of that. So prototypes are typical examples, but that doesn't mean they're the only version of a concept. Oh, that was fun. That was a fun moment for me. A cute triangle, like math jokes right there. When we get into problem solving, we can go into a whole range of ways that human beings solve problems. So we'll kind of walk you through trial and error, algorithms, heuristics, and insight. So we'll start with trial and error and algorithms. So trial and error is the process of experimenting with various methods of doing something until one finds the most successful. Literally, you try, and when you make a mistake, you try again until you come up with the method that works. An algorithm is a different way to solve a problem, right? We are going to take a methodical, logical rule or procedure and work through all the possible functions. So algorithmic thinking is the way that computers work, right? If you had a computer that was trying to solve word problems, it would come up with every possible word that could fit in there and then work its way to the one that is the most likely answer. So algorithmic thinking is complex and complicated and maybe not always the most useful way to solve a problem. People are more likely to use heuristics. So these are simple thinking strategies that allow us to make judgments and solve problems efficiently. So here's my example. I'm walking down the aisle at the grocery store and I'm looking at, let's say, spaghetti sauce. And I don't know if you've been to the grocery store lately, but there's like shelves and shelves of different spaghetti sauces. So how do I decide which jar I'm going to buy? Do I use an algorithmic approach? Do I look at every single label and compare the calories and the ingredients and, make a chart and work through all the possible answers until I identify the best possible answer? Probably not. Most of us will use heuristics. So what is a thinking strategy here? Well, I've tried certain brands before and they were okay. So maybe I'll just go to the brand I already know. I'm looking for a particular type of sauce with certain ingredients. So that'll wait out, get rid of a bunch of the possible choices, right? I'm going to kind of hone in on quick choices. It says here, heuristics are less time consuming, but more error prone than algorithms. So what we're giving up in terms of efficiency is sometimes we make mistakes when we use heuristics. And we'll actually get into some different kinds of mistakes that we can make later. What we save is a whole lot of trouble. If we had to use an algorithmic approach to all of the problems, we'd never finish anything, right? It would be a continual thinking problem, right? Where we were weighing pros and cons forever, okay? So heuristics are the approach that we use all the time and might not even be aware that we're using that. Why do you buy the peanut butter that you buy? Because you're a Skippy person, right? And why are you a Skippy person? I have no idea, because that's what my mom bought. I don't know. It just is what it is. I've never really weighed out the pros and cons of different peanut butters, okay? Insight is defined as a sudden and often novel realization of the solution to a problem. So this is kind of different from those strategy-based solutions that we talked about. Insight is like that aha moment. And you see in the image here, research from the 1940s, the monkey and banana problem. And it says, bananas hanging up, monkey down here says, oh, I like bananas. How do I get there? And he realizes, oh, I can stack these crates to get to it. All right, so I need to just take a quick break here and interrupt. I'm sitting at my dining room table trying to record this stuff for you. And all of a sudden the animals are going wild. The cat's meowing at me. The dog has had to go outside twice. Keen observers will have heard the bells. She rang the bell, and that's what we're working on. So I have to keep stopping and starting again. So I think we're good with insight. Let's keep going. Oh, we're not done with insight. When we look at brain imaging and EEG studies, the suggestion from that research is that when insight strikes, it activates the right temporal cortex. So when you have that aha moment, like you're struggling with something and you don't know how to fix it, and you don't know how to fix it, and all of a sudden you're like, bing, the light bulb goes off. They can actually see when that's happening in your brain with the brain imaging stuff. So it's kind of wild that they can pinpoint when things are happening. The time between knowing the solution and not knowing the solution and figuring out the solution is about 0.3 seconds. So it literally is like, this flash of information. What are some of the problems in solving problems? What are some of the obstacles in solving problems? That sounds better. First one is confirmation bias, and that is a tendency to search for information that confirms a personal bias. So if we were in class together, I would have you try to tell me what is the rule in this string of numbers, 2, 4, 6. And you all would likely tell me rules. Most people would start with, we add 2. So like if I said, what would be the next number? And you said 8, I would say that's correct. But the rule is not add 2. And then we keep going like this for a while, and eventually we get there. So confirmation bias is we are looking for information that confirms the thinking that we already have, whatever our bias is. If you watch this video clip, pause me and go into the notes and watch this, and I think it'll be useful. The rule here is actually any ascending number. So the next number could be 7, it could be 10, it could be 400. We're trapped into thinking it's add by 2 because that's what's going on so far, but we only have 3 numbers. So that string of numbers doesn't give us enough information yet. So the way to avoid confirmation bias is to look for information that goes against the rule and to try to narrow down what is the actual rule. So when you have people do this and you ask them what's the next number, if they say 5, we would say, yep, then that's not right. That would be a way to then confirm the actual information as opposed to confirming the bias. So watch the video clip. I think it'll be illustrating. Does it matter if we're talking about 2, 4, 6? No. What if we're talking about things like prejudice? Some situation, sexism, some situation where a person has certain thoughts about how the world is supposed to be, and they seek out information that confirms their bias, as opposed to going, well, I've also seen a lot of other things that don't confirm the bias, right? Then it could be a much more realistic thinking problem that people have. Let's keep going. Fixation is another issue related to solving problems, and that is an inability to see a problem from a fresh perspective. It gets in the way of our problem solving. So an example of fixation is something called functional fixedness, tendency to think of things only in terms of their usual functions. So let's look at an example here of fixation. The matchstick problem. How would you arrange 6 matches to form 4 equilateral triangles? So imagine that you had actual matchsticks and you're going to try to do this. How would you do it? So if we're in class, I'd have you think this through and talk at your table. Most people get stuck and can't come to a solution. So if you want to pause and try it, go ahead and pause and try it. The reason that we get stuck is because we don't think right away in terms of the three dimensions. So that's the solution to the matchstick problem. Okay, you end up with 4 equilateral triangles, 6 matchsticks. If we're talking about a fixation, if I'm stuck in 2D and I'm trying to draw this on paper and I don't go to 3D, that's where I got stuck and I couldn't solve the problem. That's fixation. Here's our functional fixedness problem. In your book, they talk about the candle mounting problem. So using the materials here, how would you mount the candle on a bulletin board? So again, if you want to pause me and think this through, think it through. So you have a matchbox and matches, you have some tacks, you have a candle. All right, so when I've had people kind of do this, what they end up coming up with are some crazy ideas. The solution is to use the matchstick box as like a tray, and then to tack the tray so that the candle can be mounted on the bulletin board. I've heard people say, like, melt the wax and try to stick it to the thing and come up with all kinds of interesting ideas. Functional fixedness is happening here because we see the matchstick box as just a container for the matchsticks, not as a thing that we could use as a tray. Okay. When we get to making decisions and forming judgments, every day we make hundreds of judgments and decisions based on our intuition. And often, most of the time, maybe, we are not using systematic reasoning, right? We're not going through and really being critical, right? How do we make judgments and decisions? It's like that, those kind of snap decisions, right? Because that feels right, right? That's more of that intuition. And I'm going to go, I'm not going to go. There is a slide here that talks about the useful part of intuition and the problematic part of intuition. The research is kind of interesting that in some cases, intuition is actually better. We get to things more quickly and more creatively sometimes than if we had gone through, more of that systematic approach. There's a guy named Malcolm Gladwell that wrote a book, and he was talking about fake art pieces that fooled these supposed art historians who are supposed to know everything, and they were using a very logical, systematic approach to try to analyze the paintings to see if they were real as opposed to hoaxes. And a whole bunch of them got fooled because they were kind of going down that other path, and it turns out that there's kind of an intuitive sense sometimes to, like, I can't tell you why it doesn't seem real, but they had a sense, but they ignored it. So intuition can go either way. Some of the other problems, if we're talking about making decisions and forming judgments, we have two kinds of heuristics that can be problematic. So the representative heuristic says that we judge the likelihood of things or objects in terms of how well they seem to represent or match a particular prototype. This is why it's called the representativeness heuristic, because how close things represent a prototype. The availability heuristic says we estimate the likelihood of events based on their availability in our memory. If something comes readily to mind because it's more vivid, or because it's something that's common, or something that's happened to us more frequently or more recently, then we might be falling into the availability heuristic. So I think the example, do I have examples on here? No. The example they had in your text for representativeness is if I asked you who is more likely to be a poet, a professor at a small liberal arts college, or a truck driver, what answer to the question would you say? Which of those is more likely to be a poet? And we'd probably all fall into the professor at the liberal arts college, because that fits a certain type of person that would be into poetry, right? I assume there's not a ton of truck driving poets, But the fact is that there's a whole lot more people that drive trucks than are professors at small liberal arts colleges. So just in terms of numbers, the truck driver might be more likely to be into poetry, right? So that's the representative heuristic. The example for the availability heuristic is like, what is your likelihood of getting COVID? Are you worried about getting COVID? And it would be more availability or available in your mind, in your memory. You might be falling into the availability heuristic if someone in your family has had COVID and you saw how they struggled, or if somebody around you just tested positive or something like that. You might estimate your chances as being a whole lot higher if it's more recent, if it's more vivid an example, than maybe the actual numbers. Now, with the Omicron surge, I don't know if that's the best example because it's spreading like hotcakes. So you might have it if you've been around somebody, but you get the idea, I hope. We're almost to the end. Overconfidence is another issue related to problematic decision making or judgment calls. Overconfidence is tending to overestimate the accuracy of our beliefs and judgment. And this connects some of the dots between some of these other things. When we talk about those heuristics, when you talk about confirmation bias, sometimes it's because we have this belief that our judgments are going to be more accurate than they actually are. So this is kind of a human problem, overconfidence, and it leads people down the path of making sometimes pretty terrible decisions. The opposite of overconfidence is exaggerated fear, and sometimes, we are overly concerned about things that maybe shouldn't be as much of a concern, and under concerned about things that we really should be more concerned about. And so, if you look at the example in the box over here, I lived through 9/11, and the concern about terrorism and if you just look at the numbers, obviously 9/11 was a terrible event, but the number of people we're talking about, 2,500 people died of all of terrorism in all of the 90s. More people died of food poisoning than of terrorism. Yet we regularly go to restaurants that probably have poor cleanliness. We don't do enough to try to keep the food supply clean, right? We regularly have these outbreaks of problems because we're not focused on some of those things. So where's the real problem? We fall into maybe worrying about something like terrorism more because it's a much more vivid situation, right? Intuition, we talked about already, that immediate automatic feeling or thought, as opposed to more conscious reasoning. So if we are thinking about something from more of a logical standpoint and using that kind of computer brain pros and cons as opposed to like just that sense. The book I was referring to before, Malcolm Gladwell, is called Blink. It's pretty interesting. If you haven't read any Malcolm Gladwell, it's worth a look. You can look through the screen if you'd like. Our last two slides, we have framing. This is another way that we can be off in terms of decision making and judgments. So the way that an issue is posed or framed can alter our decision making. So the example here is I'm shopping. There's 2 frozen yogurts. One says contains 20% fat. The other one says 80% fat free. You don't have to be a mathematician to realize that these are the same thing, but which one of those seems more gross and not the one I would buy? The 20% fat one, right? How often is this kind of thing, framing, used in marketing to get us to buy something that may not be any better for us, right? We fall for this all the time. Belief perseverance, our last one, clinging to one's initial conceptions after the basis on which they were formed has been discredited. So I hold on to that first thought I have, my first belief about something, even though other people are saying, actually, that's not true. I don't want to go wild here, but think of any political events in the last year, from some of the stuff on COVID to some of the stuff on the election, and you have people going around who are firmly believing that COVID is a hoax, and all of this stuff is nonsense, and the vaccine is not going to help you, and then they develop COVID because they're not vaccinated and die, right? This has happened over and over again. My example on the screen is a little more light and probably pretty sadly funny if you're a Vikings fan. All right, this has been too much. Take a look at this video, especially because I wasn't here today and we're kind of going through this quickly. Make sure you read this section. I would watch this as a review. Do the Quizlet on these terms, because there's a ton of terms, and otherwise you're going to be in trouble on the test, which is coming up next week. I think that's it. If you have any questions, email me. Otherwise, I will see you hopefully tomorrow. We'll see how it goes. Have a good afternoon. Take care.